Hello and welcome to another video. In this video we're going to be working on remove adjacent almost equal characters from this week's biweekly contest. And in the problem you're given a zero index word or string word, and in one operation you can pick any index of the word and change it to any other lowercase English letter. Determine the minimum number of operations needed to remove all adjacent almost equal characters of the word. Almost equal characters are characters that are equal or adjacent in the alphabet. So adjacent in the alphabet means they're one character apart, like A and B and B and C and so on. So in this first example, we have A, so we can write that down. And basically what we can do here, the best thing to do is just change these two characters here. So I guess be like this to whatever, or it wouldn't be B's, but it would be like C's. You can technically change it to whatever you want, as long as they don't match, right? So this is two operations. So in the second example, there is this one, so let's write this down as well. So A, B, D, D, E, Z. And let's just get a little bit of intuition of what we have to change first of all, and then kind of like what the best thing to do is. So these two are the same. So anytime two characters are not the same but are adjacent, right? They're either the same or one apart. We have to change one of them. And so we can change one or the other. And if we change this one, then, like, let's say we just change it. There's always going to be a way to change, by the way, your character. Like, there's always going to be an available letter, right? Because there are two letters on the side of a word. So, like, if there's a letter here and a letter here, there's 26 characters, so it's very easy to change it to a character that is not close to any of these, right? But yeah, we can change the first one or the second one. And if we change the first one, let's just say we change it to like a Z. Well, now, if the second and third character are close to each other, then this was going to be worse, right? Like, let's say this was this. Let's go back. Let's say the third character was like this, right? If we change the first character, then we have to change the second character as well. But if we change the second character, we can always change it to a letter that isn't close to any of its neighbors. And so then we can get rid of two issues at the same time, right? So if we have something like this is always going to be better to change the second character. And that's kind of the idea of this problem. So if we go back here, this is the one here. So if we go back, the idea is anytime you have two characters, you're always going to want to change the second one, because then you might fix a future problem that you might have, right? So if these are indexed, well, let's actually index these. So like index 0, 1, 2, 3, 4, 5. If this is a problem, if we change this, we can solve this problem and this problem at the same time. Where if we change the one on the left, now we're only solving one of them. So the idea is whenever there is an error, you always want to change the second character. So now let's walk through this and let's see how many changes we need. So there's a problem here, so let's just change the second character. So maybe we'll change it to like a Z. And then so also when we change this character, where should we go? Like, well, actually that part doesn't matter. We can talk about that later. But essentially, so now that we fix that, now there's an issue here, right, with these two characters. And remember, we're always going to want to change the second one. So we'll change it to something that doesn't match these. So let's say we change this to like a Z. And now we should be good. So we made, how many changes? 2, I believe. So this is 2. Now they did say change the first one and the fourth letter, but notice that when we changed the second one instead, so the characters we changed were these two, the second character and the fourth one, even though they changed the first and the fourth, it's going to be the same amount of operations. So that's kind of like, it's like a greedy solution where anytime you have something you need to change, always change the second one, because that might solve 2 issues instead of 1, and the first one will never be better. So let's look at the third example, ZYX, YX, YZ. YX, YZ. And let's figure out like what we need to be doing in this one. So let's make this bigger again. And let's see what we need to be changing, right? So ZY, we need to change one of these. So once again, we're always going to want to change the second one because, like, look here. If we just change the first one, say to an A, now we have this issue, and now we're going to have to change the second one anyway, right? And that's kind of like the crux of the problem is always change the second one, because now if we change this to like an A, now we solve both issues. We solve this one, and we solved this one over here, right? The AX, that would have been YX, that we'd have to change it again. So now let's keep going. Now there's this XY issue, so if we just want to change this one again, let's maybe change it to an A again. Now we have this issue here, XY. Same kind of thing here, right? If I changed X, let's say I changed X to like a C, now we'd have this issue, and then we'd have to change 2 characters, but because we're always changing the second one, we solve 2 issues. We're going to solve this issue and this issue here, so now we can do this. So we have 3 changes that we made, and that is the answer. So now the question is, now that we know that, we can write this down. So every time 2 characters conflict, change the second one. Now the question is what to change it to, right? How to keep track of it, and so on. And so the thing you need to realize is you don't actually need to know what you're going to change it to. You just need to know that it's always possible to change it to something that will give you a solution. So if we actually go back to this ZYX, YXYZ, this is going to give us like the last intuition for the problem. So if we go to ZYX, YXYZ, we don't actually need to care about what we change the character to. We just need to know which one are we changing, and we need to know that it's possible to change it to something. That way, we don't actually have to like store the string, right? We don't have to store the string, change any character, store anything. All we really have to do is figure out what are we changing, and then the other part is what character to check next. Those are the 2 things. So let's have a results variable, make it equal to 0, and now let's traverse this thing. So let's make an arrow over here. So we're going to check this character first. Does it? Oh, and the other thing, because, like I said, because we're always going to change the second character in a conflict, we can start traversing here. We don't need to check here, because if there's a conflict here, we're always going to check the character we're on to the character before it. So we're going to be checking like this. So here, there is a conflict. So we know we're going to change this character. Like I said, we don't really care about what letter we're going to change it to. We just need to know that we'll make a change. So we'll say result equals 1 now. We have to make this change. And now that we know we have to make this change, where do we go to next? Well, now that we know we're going to change this character, we don't actually have to go over here, because remember, we're going to be comparing. Let's write that down as well. Compare every character to the one before. So if we know we're going to change this character over here, this Y, we know we don't have to go to X and compare to Y, because we're going to change Y to a character that makes it not be almost equal to Z or X. So if we change a character, if we say we're changing a Y, we can go 2 characters forward. So now we can go over here. And now we're going to say, okay, let's compare this to the previous character, because we didn't change the X. So there's a conflict, so we have to change it. So now we'll make the result equal to 2. And same thing, we're going to change a Y to a character that makes it not conflict with both of its neighbors. So it's not going to conflict with this or this. So that's why we can move up 2 again instead of 1. So we can move up 2 because this X will never conflict with a Y because we changed the Y, right? So we'll move up 2, and same thing here. Is there a conflict? Yes, there is. So we're going to change this Y to something, and now our result will be 3. Now, there is the case of, let's actually go back in this example and see if we have something. Yeah, we can easily just like show, we can easily make one more word to show like what would happen. So let's see like what we have to do if there is no conflict. And so let's see if we have something like this, like something very simple. So if we have something like this. So what we're going to do is we are going to, and we can even add like all these characters behind it essentially if we want to. Like I guess we can add a little bit more. So maybe we'll have like C, B, A, C or something. Let's just do this. Okay. So the idea here, this will be the last one for the last part of the code that we need, is we're going to once again start the second character because we didn't start the first one. We're going to compare every character to the one behind it. And we're going to check, is there a conflict? So because we're checking here, right, we're checking this, there is no conflict. So if there is no conflict, then there might be a conflict here, right? There might be a conflict right here, which there is. So then, instead of moving the character up 2 because we changed it, now we have to move the character up 1 if there is no conflict. So we move the character up to this one, and now we check, is there a conflict? Yes. So now we know we're going to change this b to something else, right? But like I said, we don't really care what we change it to. We know it's always possible. And then if we change this b to something else, now we know there will never be a conflict here or here once we change this b. So if we change the variable, we can move it up 2 over here. And let's check here. Is there a conflict? No, there's not, right? There's no conflict between the a and the c. So once again, we're going to only move it up 1. Is there a conflict? Yes, there is. So now we need to change this b to something else. So result is 2. Then now that we change this b to something else, we go over here and there is no conflict. So notice the characters we changed are the b and the b, and if we actually do that, we will get something that will work, right? So if we change this to like z, z, and z, now we have a valid string. So that's the last part. We can write that down. So start with second character, if char and previous, so we can write this. So if char and previous have a conflict, add 1 to res and increment index by 2, because then we know the character and the one after it will never have a conflict, right? If we change this character, this will never have a conflict, so we can move up 2 characters. And otherwise, if they don't have a conflict, increase index by 1. And that's kind of the whole code. So we don't need to maintain what our character was. We just need to know it was possible to change it. Because you're always going to be able to have like a character you can change it to, so we don't really care about what the actual character is. This is going to save us a lot. We don't have to maintain a string, we don't have to break the string, we don't have to do anything. All we have to do is walk through the string, by an index, and compare the character to the one before it. And that's pretty much it. And the way to compare a character to the one before it, to make sure there's a difference of more than one, is you can just use ord in Python or get like an ASCII value. So you can get ord of, character 1, and then ord of character 2, and make sure the difference is more than 1. And yeah, that's pretty much it. So pretty straightforward. So let's code it up. Full screen. Okay, so we're going to have result. We're going to have our starting index at 1, and we're going to say while index is less than length word, right, while it's in bounds. We're going to compare, and like I said, the reason we're going to start at 1 instead of 0, because we're comparing every character to the one before it. So if there was a conflict at index 0 and index 1, we want to find that at index 1, and we want to change index 1. So now we need to check this difference, so we're going to say if the absolute value of, because like one character can be bigger or smaller, you don't really know, ord word I minus ord I minus 1 is less than or equal to 1, then we have a conflict. So if we have a conflict, we'll increment 1 to the result. And remember, if we change the current character we're on, we move up twice, so we'll increment index by 2. Otherwise, just increment index by 1. You can even have, you can even do this technically. This will also work, right? So just do this, and always increment index by 1. So that's fine as well. So we can leave it like this, right? So it'll increment by 2 if this was the case, because it'll be 1 and 1. Otherwise, it'll be 1. So that's fine too. Now, finally, we can return the result. And believe it or not, that's all you need. So there we go. So for the time, this is O of n, where n is the length of the word, and we have O of 1 space. And this is also an array problem where the constraints are very, very small. So you can actually do, like, honestly, if you wanted, you can have like a DP solution with like an index and like a last character and like a 2 characters before. Like, this is very lenient, so you can definitely, if you didn't come up with this greedy thing, you can definitely make a DP solution that easily passes, because something like n cubed would even pass, right? So yeah, it's very easy to have this pass, but this is going to be the fastest by far, because now we just have an open solution. So hopefully this was helpful, and if it was, then please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.